So good morning. I'm going to begin this morning's session with a brief introduction. Welcome to a special webinar series hosted by the Canadian Institute of Forestry and IEA Bioenergy. My name is Melissa, and I will be moderating today's session. Today is February 25th, 2016, and we are very pleased to have Tat Smith with us, who will give a presentation on mobilizing sustainable bioenergy supply chains. So here I'm going to pass it over to Luke, who's going to tell us a little bit more about our speaker today.
Okay. Good afternoon or good morning. For me, it's afternoon. I know people in North America, it's good morning. My name is Luc Pelkmans, and since January, which is last month, I'm the new technical coordinator of IEA Bioenergy, which is a technology cooperation program on the theme of bioenergy, which is endorsed by the International Energy Agency. So I'm pleased to act as a moderator for this webinar, which will be presented by Tat Smith, and he's going to present the results of a study which has recently been finalized about mobilizing sustainable bioenergy supply chains, which he also coordinated. A few words about Tat. I have a long text here. I'll pick a few things out. Dr. Tat Smith is Professor and Dean Emeritus at the University of Toronto since 2005. And since early 80s, he's had several positions, including in the Texas A&M University. He's been in the New Zealand Forest Research Institute, also in the University of New Hampshire in Durham. So he's traveled around the world. Tat is also has been president of the Canadian Institute of Forestry, and very important for this presentation, he's associate leader of Task 43 in IEA Bioenergy, which is about biomass feedstocks for energy markets. And he's also a member of the board of the Sustainable Forestry Initiative. Now, Tat's major research contributions have been in the area of sustainable forest management systems and all the different aspects of soil carbon, of harvesting, of environmental certification. So he's really the specialist on it. So with that, I will hand it over to you, and good luck with the presentation.
Okay, Luke, thanks very much, and thank you everybody for participating today. We've been looking forward to sharing this story with you. Special thanks also to the IEA Bioenergy and Canadian Institute of Forestry for collaborating in developing this new IEA Bioenergy Webinar series. And so for all of you participating today, this is really a kind of a trial run for this partnership and making sure that the work of IEA Bioenergy can be widely disseminated internationally. So we'll get into the body of the presentation here. This, as Luke mentioned, this webinar today is based on a intertask study that was commissioned by IEA Bioenergy. So during the last triennium, 2013 to 15, we had work undertaken by many colleagues then with a focus on how to mobilize sustainable bioenergy supply chains. So each of those words in this sense are critical. So we're trying to mobilize potential. We've got to focus on supply chains all the way from feedstock production areas to the consumer, and of course the context for this is that it must be sustainable. So this webinar is based on a synthesis report and many background reports that were written over this past 3-year period here. So I'm showing you now the cover page for the synthesis report, and you can see below the citation for that where this can be downloaded from the IEA Bioenergy website. So I'm really speaking now today on behalf of many colleagues. There were over 70 contributors to this project. The names listed at the top here are colleagues who either provided leadership for the different supply chains that we studied, and I'll talk more about those, or they happen to be task leaders for the tasks that were collaborating in this project. So if you're not familiar with the IEA structure, typically in any one triennium, there's about a dozen tasks or more that are focused on individual aspects of bioenergy, and this one represented then the collaboration between quite a few. So I've expressed my appreciation to those colleagues, and I'm really speaking on their behalf today. I might mention at this point that several of the colleagues who were involved in either leadership or if you will, the coalface in this project are listed here, and they're on the phone today. And so when I get through my presentation, and we're in a position then to have discussion, answer any questions that you ask through the chat board, or answer any questions that you ask orally. Luke Pelkmans will moderate that session then. And we do have colleagues on the line who have primary responsibility for some of the work, and so they might add to any comments I might make. So thanks to everybody for participating here and for their contributions to this work. So the starting point for this conversation for many of us is that we've got some serious issues related to greenhouse gas emissions and the way in which those emissions are causing climate change. And so one of the major drivers underpinning this project and all of our work is that there are significant opportunities to reduce greenhouse gas emissions and at the same time to increase domestic energy security, boost rural economies, and improve local conditions. So that's kind of that's the way in which we describe the opportunity here. So we can accomplish some really good work here through the deployment of sustainable bioenergy and bio-based product supply chains, thinking always that bioenergy takes place in the context of the bioeconomy. I might point out here, if you can see my little mouse cursor across the screen, that we're trying to get off this upward curve of atmospheric concentrations of CO2 and get on a downward curve. And so this problem can be described as kind of the wedges here of the pie, if you will, to try to get on that downward curve. And we all know then that renewables have a major role to play in helping to reduce our emissions, helping to change the concentration of carbon dioxide in the atmosphere. And the question is how much of the renewables potential can be mobilized. And so that's what's driving a lot of our work here today. We know what the target is, we know what the potential might be, but the question is how can we achieve that? And we also know from previous work, this also informs our work, that there are many estimates out there about how large a contribution bioenergy can make and do it in a way that's sustainable. Some of the higher end estimates have showed that the technical potential might be at the scale of 1,500 exajoules per year. You all will know that, many of you will know that we're actually now down at about 50 exajoules per year. If we look at total world biomass demand and use, and this is looking at both modern bioenergy as well as the bioenergy that's used in developing countries. A variety of estimates have showed we might get to 140, we might get to 250, maybe we're going to get to 500 or some other level. But the question is how much of the potential that's out there might be mobilized, and how can we describe both the opportunities and the barriers for that? So these things serve as drivers for the context for our work. To put some of these numbers in perspective, I share with you some information from a variety of IPCC scenarios that are out there. This again, these numbers at the top for modern bioenergy underpin this notion that in the developed world, the production of bioenergies may be on the order of 10 to 15 exajoules. If we add another 35 to that for the developing world, we get up to 50 exajoules per year. But in order to accomplish the potential that bioenergy would have for reducing atmospheric concentrations of CO2, bioenergy may have to have a very substantial increase in its deployment. 150 exajoules, 190 exajoules perhaps might be the level that we get to. And we need to be careful to put this in the context of major production systems that are already taking place. So, for example, current production of the forest sector, industrial roundwood, estimated by FAO, is about 15 exajoules per year. and that by ag crops is about 160. About 60 exajoules per year. So the question we have to ask now, and that all of us in many ways are dealing with day to day, is a tenfold increase likely? If we look at the sustainability criteria, is this actually desirable? And so you see the challenge then that underpinned our work here. How close can we get to these kinds of targets, knowing that it'll result in very substantial increase in production over top of what's already going on in, for example, the forestry and ag sector. So the way we've described the objectives for this project then is to look at mobilization then as in the context of, one, identifying what the necessary elements of successful and sustainable supply chains would be. We set out to develop new and existing frameworks for analytical frameworks that would seek to understand and explain the underpinning elements. We wanted to make sure that we included all elements of the availability of feedstock, conversion processes, greenhouse gas balances, land use issues, governance mechanisms, and a variety of factors that would underpin our analysis here. Our interest is in making sure we stimulate integration across complex systems, because we need to realize that we've got energy sectors and traditional ag and forestry production sectors, and that if we get successful integration across these, we might actually get better transfer of knowledge. We might get deployment of technologies then to different regions from where those production areas are now. And clearly we also wanted to inform the debate, improve governance, and contribute to mobilization globally. So you can see there's many challenges that underpin the drivers for this project. Our work was organized as described in this diagram. So we wanted to recognize that bioenergy takes place in the context of specific operational environments. So that drove us to select a series of case studies that we would use to do our analysis. We wanted to analyze those cases, then looking carefully at the operational business plan. What's the availability of biomass? What's the technology involved? Who are the entrepreneurs that are actually doing this work? We wanted to carefully make sure we understood what the sustainability criteria would be for this, looking at social, environmental, economic, and governance aspects, and conscious of the fact that there's trade-offs oftentimes. And then we wanted to identify ways in which we can kind of scale up, going from what might be viewed the micro scale at the operational analysis level to the macro scale at whole system analysis levels there, looking at demand and supply, economic performance and drivers, looking at trade-offs between biomass and fossil fuel, and then we sought to kind of integrate that to tell that story. And so that story is what we're talking about here today. So there were 5 supply chains that were selected globally in this project. And I might say then that we took both a bottom-up, if you look at us looking up into the crown of the forest, looking into the canopy from the forest floor, or as our student Lisa is looking up in our Faculty of Forestry here. But we also wanted to kind of take a downward look. So how can we kind of integrate this at the global level? In the bottom right diagram, how can we understand whole supply chains here as we go from the forest to consumers and understand how this works? And we did this for these 5 supply chains. So we want, knowing that they are significant globally now, and that these would be the first places to focus for this enhancement and identify ways in which greater potential could be realized. So we looked at boreal and temperate forests. We looked at ag crop residues in the context of bioenergy and biorefineries. We looked at regional biogas from both municipal solid waste and oil palm residues, and also recognizing that co-digestion is an important way to enhance gas yields. We looked at the ways in which lignocellulosic crops might be integrated into agricultural landscapes. As many of you know, this is one of the wild cards in the estimates that are out there, and so a real challenge as we try to get change taking place on that ag landscape. And then the 5th supply chain we looked at was the way in which pastures and grasslands, with a particular focus on Brazil, might be cultivated, and their production could be enhanced. So these are the 5 that I'll tell you more about. So let's look at each of these supply chains and look at the way the story emerges here. The boreal and temperate forests were studied under the leadership of Evelyn Tifo, who's at Laval University in Quebec City in Canada, and Evelyn's major team members are listed here in this slide. Questions that were asked there in that project were, what are the major roadblocks and opportunities for mobilizing forest biomass supply in these temperate and boreal biomes? So that team focused on looking at elements of policy, what the supply was, logistics and economics, conversion technologies, since that's so critical to match supply with technical capability, looking at the socioeconomics of these systems, ecological sustainability, with a focus then on trade and try to mobilize trade. So this again took a look at the whole supply chain and broke this down into the various steps along the way to try to understand how we might mobilize that. It's important for us to note that the current predominant forestry production system is one that's driven largely by high-value saw logs and pulp and paper. This dominates globally the operations that are taking place, and so this installed capacity here then for pulp and sawmills is what's largely driving the activity. That activity is not being driven by either the price or the demand of wood pellets, for example, but we are aware of ways in which residues could be captured out of those secondary, tertiary manufacturing operations, and the way in which forest residues might be captured from the forest then, which would supply some amount of wood fuels then to meet our bioenergy demand. Many colleagues who are familiar with the forest sector will know that right now this system that we're looking at right here is what constitutes something like 80% of the bioenergy that's being produced in Sweden, Finland, Canada, any other countries. So a big sector driven by the traditional high-value products is the one that's also allowing us to get energy capture because of that supply chain being put in place. And so one of the questions we might ask is, how might we change that? How might we substantially increase that? Recognizing that these are elements of the bioeconomy that are very significant in their importance and in the flow of material. So the recommendations that come from this project then for mobilization of forest bioenergy are shown here in this slide. So one thing to recognize here, and this is perhaps sobering to many of us, is that the most important driver to increase the use of forest biomass is actually policy-supported price. So without that policy-supported price, many of these supply chains that are currently existing now outside of what's going on in capturing secondary and manufacturing residues would not exist. But we also recognize that in trying to further mobilize biomass that's out there, there's significant opportunities for enhanced technological and institutional learning. Colleagues in Nordic countries, for example, have a couple of decades or more of experience in the way in which they can reduce costs and increase supplies. And so we're trying to point out here that technological and institutional learning is something that can be quite significant for further mobilization. Trade also offers many opportunities for biomass mobilization and can provide critical incentives then to make sure that biomass is mobilized. We find also that cooperative or organizational structures like supply cooperatives, biomass energy firms, trade centers, and these things are actually quite critical for expansion of markets. And so let's recognize that there's many institutions that are critical to the mobilization of a sector like the forestry sector. We also learned through this project that the integration of energy in forest systems is really essential to make sure that they realize the mobilization potential. For colleagues involved in forestry, of course, have been managing supply chains for centuries, and now as we engage with the energy sector, it's a question of how can they understand the seasonality of supply, what storage is necessary, what the complexity of those supply chains looks like. It's very different than managing 2 or 3 train tracks coming from perhaps parts of North America. And finally, we want to highlight the fact that achieving many of the opportunities listed actually are going to require a bit of a culture change. So society needs to recognize that, 1, we've got a problem, 2, we need to solve that problem. And so we're wanting to point out here that we need to work carefully on developing a shared vision and accepting that there's different views on how this might be accomplished. We need to work hard to develop common sustainability criteria. Right now, the debate, of course, that's taking place in the transatlantic trade would indicate that working on those sustainability criteria and developing a common sense of those is something that needs quite a lot of work. And also we need to work carefully to make sure that the technical standards for these products are clear, are transparent, and so that these would remove trade barriers and increase market transparency and public acceptance of this. So you see many ways in which the social license to accomplish this is really dependent on these factors here. I might also point out that the challenges for mobilizing bioenergy potential from the forest at the scale that's been proposed here is not a trivial problem. And so if you look at the potential gains that we might get, mobilization going from say 4 exajoules per year to maybe 14 to 28, this can only be accomplished through then a very significant change in forest management intensity. So we need to realize that as we look at the amount of roundwood now that's harvested relative to the net primary productivity of forests, net primary productivity, of course, being gross photosynthesis minus respiration of the trees, we'll have to change that ratio now in many of the major production areas to actually, if you will, squeeze more of the biomass out of the forest. And we also need to change the ratio of bioenergy to the roundwood ratio. So for that amount of roundwood that is harvested, we need to be aware that there could be more bioenergy realized now than is currently harvested. Also, sustainability issues will rise as we seek intensification of forest management, and so therefore we need to make sure our governance schemes, the criteria for sustainability are commonly agreed on, and that we know then how the potential can be achieved. Putting this in the context of the Canadian system, just for a moment, it's important to recognize that these kinds of shifts in potential that are described up here, for example, in Canada, we'd have to maybe get up to a roundwood to NPP ratio of 10%. And for us to do that, we'd actually have to triple the annual allowable cut in the Canadian forest. The AAC now in Canada is 200 million cubic meters of wood per year. So recognize then that to get that kind of growth would mean a drastic increase in management intensity, would involve opening up areas of the forest that are currently not managed. In a democracy like Canada, we'd have to be careful to work on the shared vision for this and how this is important. And you might imagine then that this would require a bit of societal change then in the way in which we view the forest and the opportunity that arises from that. So we highlight these things to if you will, be aware of the sobering reality of what these numbers mean. Keeping in mind that can be done sustainably, but we have to have a shared vision of how that can be accomplished. Let's move on to look at the ag sector now. The supply chain worked under the leadership of Nicholas Scott Benson from University of Copenhagen. Substantial contributors, Charlie Lalonde, Maria Wellish, who I believe are on the phone today from Canada, Patrick Lammers and Gian Bangan from the US, Inge Supak from Denmark, and others, Jake Jacobson from the Idaho National Lab, all contributed to this. And so we were able to get strong inputs primarily from Denmark, United States, and Canada in the way that's shown. So we had case studies conducted in these 3 countries, and these case studies showed that there actually is very real potential for further development, keeping in mind here that bioenergy sits in the context of the biorefinery. But this increase in mobilization can only be realized if there's greater political support for this, if best practices are developed and followed then for residue removal, and if there's continued development of the supply chain and optimization of that. So you see we have some challenges here logistically, politically, socially then to accomplish this. So colleagues in this project then were able to characterize, quantify the annual production and current use of primary crop residues in the different countries that were involved in this project. So there's quite a few recommendations stem from this, and I'll work down through this list here because it's important that we be aware of these. So the recommendations for mobilization in the ag sector are first of all to establish a consistent and stable policy framework. This needs to support bioenergy and bioproducts then coming from renewable biomass. If we don't have consistent, stable policy, then we're all aware of the way in which farmers and the investment community will be a bit shy. We also need to increase the awareness of stakeholders about the value in this opportunity and about the knowledge that's out there about all aspects of this. So looking at processes, cost and sustainability aspects. And we need to be careful then to use a variety of social media, educational extension programs to accomplish this. So you might imagine we're envisaging webinars that might build on this series that we're putting together now, or a way to kind of increase the awareness of key stakeholders, but recognizing there's many other media that might be utilized as well. How is it that people find out about information? How is it that they learn? How is it that their points of view can be changed and altered and help to develop this common vision? And so we're recognizing this is really critical. We also are keen to recognize that that to get the kind of stability in the business sector that's critical to get the investment, we've got to have long-term contracts for this. We can't have short-term focus, otherwise the investment community won't come to the table. We also need to provide appropriate incentives then along the whole supply chain here for all the actors that are going to bear the investment risk. So we need to be aware of what is it that farmers need, how is it that the biomass aggregators and bioprocessors need to have appropriate incentives to get the business case to go here. So it's great to have noble, high-minded ideas about what we might be doing to alter climate change, but if the business case isn't there, this isn't going to go. We also need to work hard to develop and distribute tools to underpin the confidence of the stakeholders that would be responsible for developing the bioenergy conversion technology there, about the consistency of biomass supply. Need to make them aware of quality and storage issues so that their confidence is not rocked by the dynamics that are very real in the system. We also need to continue to work hard on developing best management practices to maintain soil health. You know, the farmers in Ontario, for example, clearly state that they're not going to be interested in taking more off their land if they're not confident that it's also going to maintain the productivity for the long run. We're looking at families in many cases that are involved in these operations over 3 to 5 generations, and they have to look out for the sustainability of the system. So we need to make sure that residue removals are consistent in the long term with our knowledge of these. And then this information about sustainable practices needs to inform then credible sustainability guidelines. And so you see the way in which these guidelines for every one of the supply chains we'll talk about starts to serve as the forum where we engage stakeholders to discuss and to reach agreement and to find potential then that would meet our goals. When we ask what amount of these residues can be mobilized at global scales, there's a variety of estimates that are out there. The goal of our mobilization project was not to refine these estimates, but to look at ways in which we might achieve potential that's being proposed here. one of the numbers coming from the IRENA project estimates that 13 to 30 exajoules per year might be used by 2030. So this would perhaps double the share that's possible here. The IPCC estimates and paper with Elena Chum from NREL as senior author there for IPCC estimated that the potential for ag residues might be on the order of 15 to 70 exajoules per year. But let's recognize that there's some opportunities here that would have to be realized to achieve those levels. So we have to recognize that these crop residues oftentimes aren't as good a fuel as woody biomass from the forest to generate heat and power, and they're not grown at very high densities either. And so you see the supply chain and quality concerns that are going to be necessary to overcome to reach these kind of potentials here. So, and we also recognize that there's societal support and political support that's necessary then to achieve this. So you see the way in which we need to be thinking holistically to make the progress that's potential, that's possible. Let's move on to the biogas supply chain. This was one that I mentioned earlier, looked at municipal solid waste, all palm residues, and co-digestion as the major feedstocks for the systems we wanted to study. This supply chain operated under the team leadership of Hans Langeveld from Wageningen in Holland, and major chapters in this background report written by Heinz Sticknothe from Germany and Ruben Guisson. When we looked at how much waste and residues are actually globally available to underpin these production systems, there's quite large volumes that are out there, and so this report was careful to go through and quantify what those estimates are from a variety of sources. They looked at both municipal solid waste, which we know is a large continuous flow that might be realized as a feedstock, and they also looked at ag residues and waste. So there's estimates that are out there for a variety of crops, a variety of waste materials from agricultural production systems, and recognizing that in particular for the wet waste that's out there, this biogas production system could be fairly important. So conservative estimates of these systems indicates that biogas production might be at some 5 exajoules per year. The cost competitiveness of these systems is clearly recognized by many studies that have looked at cost supply curves. I might mention that cost supply curves were something that received focus for each of these supply chains. So we're wanting to refine our knowledge of what happens at the operational level. But clearly, biogas production systems are cost competitive. They're clearly favorable compared to fossil fuel systems, which of course is something that can be challenging for some of the supply chains we looked at, but certainly not a challenge for biogas. But there's a series of recommendations that would need to be realized to make this potential possible here. And so I have this list here taken from that background report that is important for us to understand. And you'll see the way in which consistent messages are coming through. You know, policies just are not adequate today to realize the potential mobilization that we think is out there. So these points bring these out quite clearly. In the case of biogas, there's policy inefficiencies, there's inconsistencies and intrinsic barriers that operate at a variety of scales that would need to be removed. In many cases, there's not consistent policy support, so policy may kind of come and go, and so therefore putting at risk the economic investments then that would be necessary to get the technology and infrastructure developed there. We clearly need to recognize that we're not operating on a level playing field with fossil fuels, and that could and should change. And in many cases, actually, the public image isn't as positive as it might be. And so clearly, the social license that we're seeking here to develop these systems will not be one that's very positive if we don't improve the public image of these systems in ways in which it can be important. And like other supply chains here, the business case has some challenges as well, and so we need to be careful to improve that business case. We need to recognize that the feedstocks oftentimes have low energy content per unit of feedstock. So if you look at the investment cost versus the yield, then that can be a challenge. And if logistical systems are not operating at high levels of efficiency, then we could have some challenges to the business case there. So our recommendation here is to develop biogas supply and value chains that are fully integrated with all existing residue management systems, not look at these as fragmented collection systems, but truly integrate in the municipal and ag sectors, and then make sure that there's reliable long-term financial support so that the risks by the investment community will be acceptable by them. If we can't attract the investment community to this, then these are opportunities that won't be realized. Let's move on to the way in which lignocellulosic crops might be integrated into agricultural landscapes. This supply chain team worked under the leadership of Janos Dimitri, who's at Swedish University of Agricultural Sciences in Uppsala. Janos fortunately can be on the call today, so can answer questions that you may have, and he had good support from colleagues globally then in this work. The mobilization potential that's possible in this sector is actually huge, but also has really wide error bars on it. And so I put out the IRENA estimates and the IPCC estimates here to make us aware of how wide the range is then of the potential for this crop production system. Many of you on the call may know that this for me is actually what I would refer to as the wild card in the global estimates that are out there. Ranges vary widely, and they vary widely because it's a question of how much surplus agricultural land will be available as we try to integrate production systems for bioenergy with food sector development. So that, because the error bars on that are pretty wide, the estimates on that are pretty wide as well. But we have to recognize that there actually are some huge opportunities, and the question is how can we realize that? So the recommendations that stem from their work are presented here in this slide, and you'll see some themes that are starting to be recurring ones that'll pop up here again. We need to remove policy barriers that are related to these crops that are actually operating and significant in many of our countries. We clearly need to identify ways in which the cost of this supply chain can be reduced. So we need to have ways in which we reduce costs by putting entrepreneurs to work to get some maturization in the systems here and reduce costs as operators get more experience and scale of production grows. We need to be sure to level the playing field again. That's a consistent theme that starts to come out, and concerted public policy discourse then clearly would be one important way in which this would be accomplished. Again, we need to work hard to improve the public image of these crop production systems here. And so we need to work to identify ways in which stakeholder confidence and knowledge can be increased. We need to increase the availability of information. And again, this gets back to this question of the various media that might be out there. You know, how is it that people learn? Where is it that they go to get new knowledge? Is that knowledge actually compelling and able to move them across to a new space conceptually? And how can we work carefully together then to broaden public discussion and get down to some discussion of the true cost? Because let's recognize that if we do nothing, we're already suffering the consequences then of our inattention to the links between climate change and cost to society. And finally, we need to promote holistic approaches to realizing the value of biomass here, looking at the provision of all ecosystem services. If we continue to have kind of fragmented, bitsy focus on things, then we won't achieve the potential because of a failure to kind of understand things at the whole system level. The fifth supply chain that we studied in this project dealt with the possible enhanced cultivation of grasslands and pastures in Brazil. This operated under the leadership of Göran Berndes from Chalmers University in Sweden with input from a from a really comprehensive team of colleagues from Brazil. So thanks to everybody who was involved in that project. The context for mobilization in this project was that there is actually quite a large land base that could support both the sugar crop production systems as well as profitable oil palm biodiesel production systems. So there's actually some 40 to 60 million hectares that could be profitably developed here to increase the production of the systems. And the key to understanding the way in which the supply chain operated was to realize that they were seeking to identify ways in which this could be done without causing direct land use change emissions or impinging on protected areas. And so this is really important to recognize that these were criteria for developing sustainable systems that we wanted to put out there. The historical expansion of the sugarcane area in Brazil is in many ways, we could view that as quite a success story as we've risen and increased production systems over time. The work that took place in this project to identify ways in which this might be further expanded was done, as I said, in the context of trying to figure out ways in which this could be done without serious change in land use, and certainly without impinging on food production. So let's look at the barriers that were identified for mobilization in this sector. And one of the things that became clear in this project was that there's actually few technical or economic barriers for this production system. The legal conditions for production are pretty well established. The production systems are mature, and so we've already realized how the cost to the operators can be reduced over time. Many of us are aware of the way in which when we put entrepreneurs to work, that over time they figure out a way to reduce costs, and so the cost of production of sugarcane in Brazil is very low compared to even fossil fuel systems. There's technology and capacity to rapidly increase production in response to demand. So this is one that operates in pretty tight economic market operations there. And there's actually been pretty good progress on infrastructure investments then to strengthen capacity and looking at what the expanded export routes would be. To sustainably increase food, biomaterial, and bioenergy output actually does require some structural shifts and incentives that will reward higher productivity. And this is important to recognize for some sectors, like where under cattle production, for example, ample supply of new land in frontier regions kind of fostered a culture that may not have led to increases in efficiency, but there are huge opportunities to do so. So there needs to be a bit of a shift in the cultural here. So looking at the important opportunities for mobilization, then these are listed here on this slide. Joran and his team from Brazil have done some good modeling work then, and these modeling and assessments actually revealed that there is huge mobilization potential. So this production can be multiplied without converting forests and other native ecosystems into ag land. The expansion of irrigated systems can be quite substantial and can boost production in water-limited systems in ways that actually will get substantial increases in production, but without causing problems in water. So as we look at the bioenergy to water nexus, then this is one that's important in our work. There's also realized out of this modeling work then that the opportunity for large-scale mobilization that avoids natural ecosystem conversion is quite substantial. But this will require incentives and regulations then that complement the kinds of systems that have been put in place. And finally, decision support systems that integrate across the variety of factors have been developed and are now useful for actually guiding the mobilization. So you see the way in which this has led to some important development of opportunities. I like this diagram that comes from their work because it identifies the way in which we might view points of view that are out there, points of view in the conservation community, points of view in the ag production community, points of view that might be viewed as purely interest in dispute, and campaigners that might be just interested in kind of stirring the pot. And but let's recognize that we actually can achieve sustainable production systems here that achieve find the ways in which we get a win-win between conservation goals and agricultural production system goals that actually are sustainable. So through this work, let's focus on these wins that can come out of this dialogue here among the stakeholders. At this point, it's clear that there is sufficient area to meet both conservation and production objectives. There's large scope for productivity gains. The environmental issues are really not the only reason why productivity gains are perceived to be important. Actually, the ag sector actually has a huge share in the interest in these productivity gains. And environmental protection is actually a complex multi-stakeholder process with multiple initiatives. And so working together to achieve these wins is pretty critical for this. So overall, wrapping up then, overall what this project sought to achieve can be described in this diagram coming from the IPCC report, where we have two axes here we might portray production systems. They might range in this axis from systems that have poor governance to ones that have good governance. They might also be described as ways in which they might range from systems that are globally oriented to achieving fairly high ambitious goals to ones that are just perhaps regionally oriented. So as we try to drive the development of production systems to the bottom left-hand quadrant here of this, we might anticipate that we have potential for high biomass utilization, as described here for forests anyway, where residue streams might be fully utilized, land use conflicts would be avoided, and ecosystem services would be preserved. So you see the way in which we get these holistic goals achieved. We've cooked this all down in this synthesis report then to this summary of the way in which the opportunities to mobilize bioenergy might allow us to realize the benefits, and have boiled this down then in a way that would sit over top of all 5 of these supply chains then in technical, institutional, and economic opportunities then that would be necessary to achieve these goals. And so you'll see, you could study this. I'm not going to spend more time on this now, but you could study this to see in a way in which these need to be where our continued focus needs to be applied in all these supply chains then to realize the social, economic, and environmental opportunities that are here. So thanks very much. I'll turn this over to Luke now and make sure that you're aware of how to find us. So Luke, back over to you. Thank you very much.
Thank you, Ted. I think I'm muted because you have to press it. So if you can hear me, then it's okay. So thanks for the presentation. I think now we can open the call also for questions from the audience. I think there's 2 ways that you can put questions. There is some discussion boxes and you can type them down. I'm not entirely sure how exactly that works. But you can also, there's something. You can also unmute yourself and ask something through the phone.
So just to let everybody know, I'm just going to unmute everybody right now, and that's going to take care of everybody at once. If you don't want to be on the line, or if you want to mute your own line, you'll have to press *6. If you change your mind and you'd like to remute your line again or unmute it, you can just press *6. So that'll sort of toggle between both of them. And just to sort of let everybody know before you ask a question, please just let us know what your name is and where you're calling from. Just give me 1 moment and I'll unmute everybody's line.
Okay, thank you.
The conference is no longer in lecture mode.
Okay, I see somebody raising a hand, which is Peter Coleman. I see it on my screen. So, Peter, are you there?
Liz MacDonald and I are sitting together on the same phone, so she had a question and it's my username, so I'll pass you to Liz.
Okay.
Hi, can you hear us?
Yes.
Yes.
Okay, I just wanted to check. You showed some quite large figures at the beginning about the potential, and you were talking about the IPCC work. And so effectively there's two parts to this question. I wanted to know which particular IPCC analysis this was, if this was for Kyoto or Paris, but also when you decided the potential, particularly when you were going through the individual case studies, did you consider the environmental and carbon sequestration requirements? I'm thinking in particular about sequestration to soil, sequestration of carbon in forests and so on, and how much did that influence the numbers, the potential numbers that you put forward? Thank you.
Yeah, thanks for your question, Liz. I should clarify here that this project did not attempt to critique or develop new quantitative estimates at the global level for what the production potential was. So the underpinning assumption that we would have in these factors that would be necessary to increase mobilization potential would be that environmental criteria and carbon sequestration criteria would need to be satisfied and considered in order to scale up to the potential that might be realized. So Liz, what we're really doing is putting out there in this work the context for the levels that might be reached, but we're not attempting to say you will reach it if you do these things. The question is, how can you take these things into consideration to reach a level that might be the max, understanding then that these criteria that you've given us examples for here, and as we all know, there's a big long list of these. We should include social criteria as well and some other factors that would that in many ways can be viewed as constraints on the mobilization potential, but we also want to recognize in many cases that there are positive benefits to be realized, for example, on ecosystem services that maybe aren't getting as much attention now in the true costing and the way in which the potential cost benefits might be realized. So I hope that is clear in answer to your question, that we're absolutely insisting that environmental and carbon sequestration criteria, as they're agreed upon, would be built into the development of these systems as they're mobilized.
Okay, thank you.
Okay. Yeah. I suggest we go to the next person. We have here a chat from Jeffrey Skier from IRENA. Are you there also?
Yeah, I'm here.
Okay.
So
you talk about productivity gains, mainly in agriculture.
Yeah. So I mean, it's just something implicit in the presentation. But if you look at the potential for producing, more crops, for bioenergy crops in agricultural landscapes or in pasture land, I mean, it's all about increasing the yields on both types of land, isn't it? And I didn't see in the list of recommendations steps to take that was included. So I'm just suggesting that it's important to consider things like involving development agencies to get the yields higher. It's not necessarily obvious in terms of what's immediately possible, but if more development aid were focused on increasing yields, and after 10 years, maybe you'd have some land liberated and available for bioenergy crops.
Yeah, really good point, Jeffrey. Thanks for bringing that up. I think that it's certainly in our minds critical to identify where the resourcing might come from and where the new knowledge might come from to get those higher yields. But implicit in the last three supply chains that in ag residues, in lignocellulosic crops, and clearly in the points that come from Brazil, then getting higher yields so that we make sure there's kind of an intensification of production on the production base there. It's implicit in the way in which a lot of those potentials will be realized. And as you'll know, Jeffrey, that's one of the reasons why the error bars on those estimates are oftentimes so large. What is the land base and how can you do that in ways that's sustainable? And what's the range in yield increases that are possible given the realities of the system and the way in which the mix of incentives and financial support and market-based profits that might be generated would be realized. There's colleagues on the phone here from the ag sector report. Whether they want to contribute at this point to help underscore Jeffrey's point or to make more points is certainly welcome.
Sure, I can start on. This is Maria Wellish from Agriculture and Agri-Food Canada in Ottawa, and I'll invite Charles Lalonde to jump in. But certainly, we were participating in the ag residue case study, and certainly from the I think both the Canadian and the U.S. case, the reason the collection of residues, and when we say collection of residues, it's partial collection. It's not 100% of the residue that's removed from the land. Is possible is because of increased yields. So I think that whole opportunity is come about because of major increases that have been made in corn yields that we expect to continue for some time. And as you increase corn yield, grain yield, you increase biomass yield, so you have almost in some cases surplus biomass, and those create these new opportunities. Charlie, I don't know if you're on the line.
Yeah, this is Charlie Lalonde from the Ontario Federation of Agriculture. I think when you're looking at increasing production on marginal lands, you have to look at a holistic approach. Agricultural crops need drainage. At times they may need irrigation. If you're going to get production, you're going to require the appropriate fertilization, the knowledge and the equipment required to plant the crop and harvest it and bring it to market. So all of these factors come into play, and in underdeveloped areas, each one of these factors is a major hurdle to overcome.
I think it's an interesting discussion point. There's also a comment here from Manuela Sinar. I don't know if I expressed it very well. She had a comment on the irrigation part, irrigation to raise the productivity in Brazil. Maybe Manuela, could you comment a little bit?
Just a note, some people are only connected by phone, so they, over the internet, so they won't actually be able to participate over the phone.
Okay.
They may not be able to with us.
Yeah, she's in listening mode. That's what she replied. That or maybe also somebody from the team in Brazil. Could you comment on that? So with the issue of drought and irrigation.
Thanks, Luke, and thanks for your question, Manuela. We can see that on the screen here and see that you're in listening mode. And so you're mentioning the concern about the amount of irrigation water that might be available, and what the context for this is in situations where there might be some drought. I can't comment specifically on the way in which the range of precip variables was dealt with in this project, and I'm not aware of colleagues from Brazil being able to be on this call today. If any of them are, then they might be able to speak up and give us feedback on this. I might mention that Joran Berndes, the team leader for that supply chain work, is working with GBEP in a project that deals with kind of the bioenergy water nexus. Goran's got extensive work going on in Brazil with colleagues Gert Sparovec and others that are there. And what we could do is make sure we put you in contact with them to answer any specific questions you have about this and the way in which the concerns that you're mentioning here actually affected their production estimates and how that affects then the sustainability of the system. So I hope that's helpful.
Okay, I see that Manuel is answering. Thank you very much. So it would be good to get her in touch, I guess. Somebody raised a hand here also. Mahmoud Ebadian. Are you on the line? Hello?
Yeah, I can't tell whether he's on voice. Maybe Mahmoud, is your phone muted, or can you type something in the chat box there?
He's typing something now.
Maybe what we could do is go on to another question and then come back, or...
Okay, at the moment I don't see any other question, so nobody raised their hands or put in a question on the chat box. Is there anybody else?
Two people were typing, maybe?
Yeah, I think that, yeah, I see Peter Coleman here, but I guess that's Liz again. So Liz, do you have a question? Another question?
Yeah, it was an observation, so it's Liz McDonald from the UK again. It was in relation to the biogas case study where you obviously said that, you know, technology is quite expensive. And I wondered whether, as part of the case study, or if you're going to consider looking at the wider value of biogas, and particularly using waste, food waste and manures and slurries and so on, because when you look at the wider benefits, I think that's when the cost-benefit of the technology, such as anaerobic digestion, starts to add up. So when you think about, for example, displacement of fossil fuel fertilizers with digestate, your cost-benefit analysis changes quite a bit. So I was going to put in a suggestion that this is probably a useful thing to do. So we shouldn't forget that these technologies aren't purely about energy. And just as a final comment, I think an important point to make is that it was a point you almost said it when in the conclusions of the case study on the lignocellulosic crops. And I think it's what you need to have is a level playing field. So you don't want a policy for lignocellulosic crops and a policy for forestry crops going to direct combustion and a policy for biofuels. You want your policy and your sustainability criteria and your best practice to be based on the feedstock and not on the end use. And then that way you'll open up the market.
Yeah, thanks very much for your input, Liz. I'm really pleased that you're on the call and that you could make those points. They're really important ones, and bring out some nuance and add to the ones that we had listed there. So thank you for that.
Okay, and I can confirm, look here, my colleague also worked on the biogas case study. I can also confirm, yeah, at the moment biogas is compared as an energy, only at the energy level, but there's so much to do with the digestate. Here in Belgium we have the situation that we have too much manure, we have to export the manure, but we still use fossil fuel fertilizers, so that's really a crazy situation. So there's really a lot of opportunities in that. I think they covered it a little bit, but this is indeed a very important message for that. I still have Mahmoud Ebadian here, who has raised his hand. Are you there?
residue 你放在地里面是保护土壤的时候，还有一个就是这怎么更有效的就是转化成carbon或者是一些土壤carbon。不是说光放地里面让它自己转化，自己转化效率就低或者什么之类的。下面说这个我现在要30岁就好。
I hear somebody speaking, but it's not very clear to me.
Yeah, just a note to folks on the line, if because all lines are not muted right now, any conversations we can hear them over the phone line. So if you want to kindly just mute your lines by pressing *6.
So Luke, if no more questions come through, I notice we're at 11:05 here Eastern Time. It may be appropriate to bring this to a close, unless somebody else puts up their hand or types in a chat.
Okay. Yeah, I don't see any new questions here. Of course, everybody is still welcome to point. There is one question here from Matthias Svensson.
And I see Maria Wellish has her hand up as well.
Yes, yeah. Matthias Svensson had a comment about the possibilities of double cropping in between cropping systems. I don't know, Matthias, are you on the phone or just listening? He's muted.
Sorry.
Can somebody comment on double cropping systems?
Yeah, Maria, would your team be? Could you speak to double cropping, or is Yanis Dimitri still on the line?
I don't know.
Leave alone here. Double cropping would work well where the growing seasons are long enough to entertain two crops. In the more temperate and northern climates, a crop could be followed by what is referred to as cover crops. And the idea is that you want to keep living roots in the ground as long as possible so that you are mitigating against soil erosion and keeping the nutrients for the following crop.
Okay.
Thanks, Charlie. Luke, I noticing that, and I just lost it there, but there's actually a question from Ken and Noel, and this might go back to Charlie or Maria again. Recommendation for mobilization, ag crop residues, mentioned developing and tools. Wanted to have some elaboration on the specific tools that might be developed here. I know Maria, Charlie, you guys have given this a lot of thought and maybe well placed to comment on that.
Okay, do you want to start, Charlie, or?
No, you go ahead and I'll supplement.
Okay, so I guess certainly getting I think reporting basically on Charlie's work and the OFA, but certainly getting a very good handle on the residue availability, a good biomass inventory, appropriate at the right scale is important. Understanding obviously your soil types and soil carbon content, having that kind of background information to know if this is even a viable option, and then like anything, conducting trials to see what kind of removal, how that will impact the soils. And so you can provide then best practices and guidelines for, what types of conditions that you would harvest, how much residue, and, suitable for a certain rotation, for a certain area with certain soils. So those are types of tools that it takes several years to develop and have been under development in Canada and the U.S. certainly. Charlie, do you want to take it from there?
I was just going to add briefly, when you're looking at removal of ag residue, you have to look at the soil health issues. So the soil requires that we return a certain amount of residue every year in order to maintain that soil. And one of the significant factors is the tillage system. So producers that practice either minimum tillage or no-till usually have soil health at a very high standard because it allows for a lot of microbial activity. So as Maria indicated, when crop yields such as for corn or for winter wheat are at a very high level, it's possible to remove a portion of that residue. And the work that was done in the U.S. and the work that we're doing in Canada, we're looking at removing approximately 30 to 40% of that residue, leaving the rest on the land to protect against erosion and to support soil health.
Okay, thanks for the answers. Meanwhile, there's quite some chatting going on here also. I got a remark here from Ireland on the biomass resources are so poor that there seems to be no real improvement over the last 10 years. I'm not sure if this is really about the production of biomass or about the use of the bioenergy. Shane Hogan, we had this remark here.
And I'm not aware of Jura Devlin being on the call. Jura, are you on? I don't hear Jura, but Shane, we can put you in touch with colleagues in Ireland who may be able to open up a debate discussion with you.
Okay, then. Yeah, I think that would be best to have contact also with the people in IEA Bioenergy Tasks. Kees Boon from the Netherlands also has a few links which he put there, so thanks for that, Kees. I think the second is also quite important, is that at the moment there's a consultation going on from the European Commission on their policy on sustainable bioenergy after 2020. So I think this is quite crucial also in our sector that we can provide good feedback. I see here that Mahmoud Ebadian, we tried to reach you, but he put now his question in writing here about the mobilization. Let's see. It requires large number of harvest handling equipment and land to store biomass. Yeah. And workforce, do you see that as a barrier to increase mobilization of biomass? Do you have something
so Luke, I
on
might just turn that back over to Maria and her colleagues. They were the ones that helped build it.
I'd say, thank you, Charlie. I think you have some information from AGCO on that you might be able to...
Currently, with the agricultural practices being used, biomass is considered for regional strategies. We have not reached a point where we could move biomass from one end of a country to another. So to give you a sense of a range, bioprocessors are actively seeking biomass in a 50 to 75 mile radius, so roughly 100 kilometers appears to be the transportation limit for biomass. Once we can densify biomass cost effectively at the farm level, then you could consider in time a system where biomass becomes a tradable commodity. But we are not at that stage now.
Thanks very much, Charlie.
Yeah.
Mahmoud, I hope that's helpful in answering your questions there. Good question, because those seasonality of availability and storage of supply and logistical system is pretty critical.
Yeah, and I'd add also, in the Canadian scenario where you can't always harvest before winter, you're looking at perhaps harvesting at different times of the year to make that a more manageable piece, and then you also a way of organizing your machinery and human resources costs, so forth. So you might be doing both a combination of fall and spring harvesting of the same material, off the same land, but just breaking it up into two segments.
Maria, thanks also for your comment here in the chat box about letting people know where to find more information. The slide that's up now shows how to contact any of us at IEA Bioenergy, but I also might mention that at the beginning of the slide presentation there was a download link for for the synthesis report, and we can make that information available to people as well. Yeah, one more. Yep, there it was. So this this link here is to the main IEA Bioenergy website, and the synthesis report that we've been talking about today and building on today that's the URL for that.
Yeah. So actually, this webinar will also be available again on the IEA Bioenergy website. So you will have both access to the full report here, but also you can look back at the presentation. You can even hear it back. So you can, it's all being recorded, and you can listen again if you would like to do that. There's a few questions here. I suggest that we cover maximum 2 or something, and then we finalize. So I think there's an interesting comment here on combining increasing or maintaining biodiversity and increasing yields. Is that being treated also in the study?
Yeah. So thanks, Matthias, for that question. I think, in my mind, this goes back to the question was asked by Liz McDonald at the outset there about the criteria for sustainable systems. We think overall there is opportunities for increasing yields and for increasing and maintaining biodiversity, and so one needs to take a holistic landscape approach to this. Be aware of how organisms at either the kind of square meter scale or at regional scales need to be understood, and so clearly the criteria for sustainable systems that we've been urging the development of for every one of the supply chains we looked at would build that in there. So biodiversity all the way from the gene to whole population levels would be something that's pretty critical. So I hope that helps answer your question. I would also say that that some of the challenges are in making sure that where these systems are developed, where the criteria and indicators are developed, that we have best management practices that will achieve those as well. And so, Matthias, you'll be aware of the work that's taking place around the world to actually develop an empirical understanding of how we take theory and actually translate that into real operational guidelines on the ground. And in some ways, we refer to that as the output legitimacy of any of the systems that are there. You know, it's great to have lots of good theories, but we actually need to know how to translate that into action in specific ecosystems and on specific soil types. And so, to some degree, that's part of the challenge for our research programs, and we need to make sure that there's adequate investment then in those R&D programs to make sure that these win-win opportunities, as we're describing them here, can be realized in ways that there's good case studies, there's good empirical basis for that. Hopefully that helps.
Okay, thanks. There's a few remarks here from Mahmoud that he's doing a research and he's happy to share his results. So also thanks for that. I think there's no more real deep questions, so I think we can close this webinar. On my behalf, thank you everybody for listening. I hope it was interesting for you. And as mentioned, everything will be available, or the study is already available on the IEA Bioenergy website. And the webinar will also be made publicly available on the same website. So thanks on my behalf. Maybe Tat, you want to say a few words? Or?
Thank you, Luke, for moderating, and thank all of our participants for being online today. We appreciate this opportunity and hope that this conversation will actually lead to more collaborative work together. We think there's huge opportunity here for building community around these topics. I'd lastly thank colleagues at the Canadian Institute of Forestry for their support for this, and for the way in which the technical system comes together to make us all possible to have a global conversation here. So, back to you.
Well, thank you, Tat, and thank you, Luke, thank you, Tat, for presenting, and thank you, Luke, for reading today. And if there's any other questions, again, there's contact info at the end of the presentation. And thank you to all the participants for joining us from across the world. All right.
Okay.
Have a good day, everybody.
Thank you. Have a good day.
Okay. Thank you. Bye-bye.